Alrighty, welcome back. This is Ms. Abner, and we are in the middle of section 4.1 for our notes for reasoning and proof. So you should be down on page 3, and we are going to start with a conditional statement or an implication. So this is one of those, well, if you're outside and it's wet, then it must be raining. This is those. So these are your if-then statements. So if P, then Q, where P and Q are declarative statements. Okay, we can symbolize, this can be symbolized with P. Nice new funky symbolization, arrow, Q. So now we're going to pull these apart. This is just a bunch up here. This is just a bunch of fancy math speak. So if you were a little confused, that's fine. Not everybody understands academic language, first off, until you can prove it, and then it makes sense to you. All we're worried about in this whole big funky thing is if P, then Q. Okay, so let's rock out. So the hypothesis, the if part of the sentence. So for the hypothesis, we're looking for the if part. And for the conclusion, we're looking for the then part. Those are the two key things that we need out of this, the if and the then. So, example, if it is raining, then it is cloudy. So, if it is raining, so it is raining is the, if you're at home, you're going, hypotenuse, examiner, hypotenuse. You are hypotenuse, not hypotenuse, hypothesis. Sorry. Hypothesis. Okay. It is cloudy is the conclusion, because that's the if and this is the then. So conclusion. So since we have our if and our then, now we can move on to the fun part. So identify the hypothesis and the conclusion of the following. So if two angles have the same measure, then they are congruent. Okay, so we're going to look for the hypothesis. So the if part, if. Then the conclusion is going to be the then. So I'm going to go, this is my hypothesis. And this is my conclusion. Okay. So now that we've gotten that we can pull them apart, if you notice there's one key thing that happens in between the two, a comma. So if you're unsure, look for the if part, which will be before the comma, and the then part, which is usually after the comma. Now, granted, that is not always the case, but it is most of the time. Okay, so now let's look at the if two angles form a linear pair, then they are supplementary. Okay, so let's look at the if part. If two angles are a linear pair, okay, then they are supplementary. Okay, now let's take a look at the wording there. So let's look at our if. So if, linear pair, meaning they form a line. Oh, that's horrible. Okay, so if they form a line, well, these two angles 3 and 4, let's change to a neutral color. Well, look, they do form a straight line, okay? The line is just split by this side. Cool. Sounds like a plan. All right, so then they're supplementary. Well, let's look into what supplementary is. Well, supplementary means they add up to 180 degrees. So that means this plus this is 180. This is what it looks like mathematically. M means measure. So the measure of angle. So we're looking at the measure of angle. So this means measure. Oh, so to use a symbol when I'm telling you what it means. Of angle. So measure of angle. When I write it, mine looks like this. And I always put an arc in there because to me that lets me know that that's not an L or a less than symbol. So measure of angle, I always put the little line in there to make sure that you know that it is an angle that I'm talking about. And that's not like an L or a less than symbol or anything else like that. But there you go. That's what those look like. All right, so now let's put some of this to work. We should now be on page 4. So we're going to take a look at it. Using postulates about segments and angles. Okay, cool. So we're going to use some postulates. So we know that postulates from the first video are going to be statements that we just accept as true. Okay, so my given is that RT is equal to 5x minus 12. So RT being this whole shebang, this whole space here. Okay, and then it says find the value of x. Well, here's an easy way to think about this. So it says using the segment addition postulate. That's this over here. So segment addition postulate means if I have this segment here, segment meaning no arrows on the end, dots on the end. Okay. I'm going to name this A, I'm going to name this B, and I'm going to name this C. Okay. This here is a part. AB is part of segment AC. And this is a part. However, this is the whole. The parts have to add up to the whole. So with that being said, if I'm writing this in math talk, because, you know, they like to see that sometimes, I would say segment AB plus segment BC is equal to segment AC. The parts have to equal the whole. Okay. So we'll make that our side note. Let's give it another funky color, not orange. Hold on. Weird pink color. It doesn't really look like pink, but we'll call it pink. So say the part must equal the whole. Okay. Now that we have our little side notes there, now we know what we're doing. Okay. So since our parts have to equal our whole, it says use the segment addition postulate. So we're going to add some segments. So let's look at this. Okay. So RS plus ST, right? Those are our parts, is equal to RT. Okay. Imagine those are all closed circles because apparently when I'm drawn them, they're opening. Anyways, so now I'm going to substitute these values. So for RS, instead of writing RS this time, I'm going to write in this. So X plus 2 plus, make the second part this funky pink. So this one is going to be 3x minus 8. And then it is going to equal RT. And I'll just make RT. I want it to be, wait, no, that looks ugly. We'll go this darker orange color. Okay. 5x minus 12. Now that we have our entire equation out there, and we know that our parts have to equal our whole, what we are going to do now is use your algebra skills. Okay, so we're going to combine like terms. And then we're going to use inverse operations to isolate our variables. Oh, there's only one variable, so we don't need S there. It's the variable. Okay. This is your reverse PEMDAS. Okay, here we go. So the first thing I'm going to do is combine like terms. Well, I want to know what terms that I have that are the same. So I'm going to solve in a different color that I didn't use. So I'm going to solve in purple. Okay, so the first thing I'm going to do is find my terms that are the same. So AX is the same as 3x. Mind you, I have not gone across the equal sign because going across the equal sign requires me to use an inverse operation, which I'm not using yet. Okay, so I have 3 x's and I have another x on this side. I have 4x, and then I have a 2 and I have a negative 8. Well, if I have 2 and a negative 8, so if I have $2, but I owe somebody $8, well, I'm going to pay them the $2, then I only owe them $6. Nothing changed with the 5x plus 12, so I'm going to keep my minus 12. Okay, moving on to the next step. This is where I'm going to use, so this was the first thing we did was combine like terms. So now I'm going to use inverse operations to isolate the variable. So that means I'm going to have to move some things from one side of the equal sign to the other. I'm always going to go to where my x term is positive. So since my 5x is bigger, I'm going to subtract 4x from both sides. That cancels out. That leaves me negative 6 is equal to x minus 12. In that case, I'm going to move everything away from the x, so I got to move the 12. So I'm going to add 12 to both sides. I'm left with a positive 6 over here is equal to x. Well, we know that 6 is not an x. So in this case, order does matter. It reads like a sentence. So I needed to say x is equal to 6. So how we know that it says that is that you read this as x is 6. And if the equal sign, you see it as the word is, then 6 is not x. You can say 6 is x because it's not as a 6. Okay? So now we're done with this one. Pretty easy. We used our algebra, we used our geometry, we are good to go. Okay, now let's look at the next part. So this time, and keep in mind, if you want to pause and go over that problem again, you certainly can. That's the beauty of a video. You can always pause and rewind and go back and see which parts you need to revisit. Okay, so now we are looking at our second example. So it's given that angle XYZ is a right angle. So right angles equal 90 degrees. So we're going to immediately make that note to ourselves that a right angle is 90 degrees. Without the degree sign, it's just 90. And that doesn't help us. So make sure we put our degree sign there. So this is still operated under the parts equal the whole. So the addition postulate is usually goes along with, doesn't matter if it says segment in front or angle in front, it's still the two parts have to equal the whole. So part plus part equals the whole. In this case, the whole is the full 90-degree angle. So I'm not going to draw out the same example like I did with the segments, with the angle. We are just going to operate with the visual that they give us here. So we're going to find, so it says angle 1 is 3x. So they said that this in here is 3x. Then they said, because they tell us a lot of stuff today, then they said that angle 2, so this here, is 12x plus 15. Okay, so now we know what our two parts are. And they want to know the measure. Mind you, they're not asking you for the measure of, point this out, they're not asking you for the measure of the entire angle. They're not asking you for this because they told it to you already. They are asking you for actually, let's go purple, hold on. Okay, they're asking you for the measurement of angle X, Y, W. X, Y, W. So they want the measure of this angle. They want this. Well, look, that is the same as the yellow piece that we colored in already. So now we know what they're asking us for. So it's going to be two parts to solving this. First, we have to find out what X is. Then we have to plug in X to get the answer they're looking for. So let's rock. First thing we're going to do is set the parts equal to the whole. So I'm going to take my part, 3x, and I'm going to add it to 12x plus 15. And I'm going to set it equal to, well, what am I setting it equal to? Oh, look, that lovely 90 that they told me. Let's use a different color. Make it black. 90. Okay. So I have my parts. I have my green part. I have my yellow part. And then I have my whole. Okay. Got all my things taken care of. So now I'm going to solve for X. So for this part, we are Easy enough, we can do that, right? We're going to use our algebra skills again. So we are going to use our okay, so that means we're going to combine like terms. Then we're going to isolate the variable. Okay, so I'm going to use my algebra. So, okay, I need my like term. So 3x's, 12x's. Oh, look, together I have 15 x's. Well, there's no other number over here to combine it with, so then plus regular old 15 is equal to, well, this number hasn't changed, so we're just going to bring it down. Now, when I do my inverse operations, I am looking at moving everything away from the x. So since it's at reverse PEMDAS, I'm going to do addition or subtraction first before I do the multiplication or division. It just lessens the amount of things I have to divide. So I'm going to subtract 15 from both sides. That goes away. I'm left with 15x is equal to, well, what's 90 minus 15? Well, 90 minus 5 is 85. And 85 minus 10 is a big whopping 75. Okay, now I'm going to divide both sides by 15 because I need the x by itself. So then my 15s again are going to cancel out. And I'm going to have that x equals, well, there are 5 15s and 75, so x is going to equal 5. I'm not done though. I now just know what x is. I don't know how I did in yellow because that's going to be misleading. I know what x is now. So now I have to substitute x into my equation to find the value of angle 1. So okay, so now I have 3, keep it color-coded. So now I have 3x. And all I'm doing is substituting in the 5. So now I'll have 3 times the 5. Well, 3 times 5, we all know is 15. So in this case, what we are looking for is the measure of angle, x, y, w is equal to 15 degrees. This purple is what they asked me for. So since that is what they asked me for, oh, that's not what I need to do. Sorry guys, hold on. Sorry, just resizing it. I don't know what I did to make it go bigger, but my bad. Okay, so since that's what they're asking me for, there's my answer. So like I said before, I don't want to make this an egregiously long video. So we've covered the addition postulates. So now we're going to move on to pages 5 and 6 of your notes in the next video. See you there.